What?
Okay, my friends, here we go. We are ready for practice test 2, problem number 9.
Yep.
So here we go. Find the probability of being dealt a 4-card hand. So stop right there. I know my denominator will be 52C4. That's a 4-card hand.
Yep.
Now, what do I want? I want exactly 2 queens. So what does that look like? 2 queens. How many queens are in the deck?
4,
So 4C2. I heard somebody say 4C2. That's right. There's your queens. Now, this is one of those tricky ones. There was one on the first practice test too, so there'll probably be one on your test. What makes this tricky is, all it talks about in the problem is 2 queens. But remember, you gotta have 4 cards. So it doesn't mention the other 2, but you know you have to have them. And what are they? Not queens, right? So how many cards in the deck are not queens? 48. And we are going to pick 2 of them. All right, so everybody's got a calculator? Gotta type it in. Did you get, basically 0.025? 0.024999? Everybody should be typing it in. Those half points add up when you start, not getting the right answers.
Yep.
All right, number 10. What is your thought on number 10? Read the problem and what?
Pyramid problem.
It's a tree diagram, a pyramid problem, exactly. So you're gonna have here's level 1 and here's level 2. Now, what are the 2 things we're pyramiding? Popcorn and soda? So let's read the very last part of the problem.
Soda.
Find the probability that they will serve soda. So, bottom row is soda, not soda. Everybody okay with that? And then, popcorn. And no popcorn. Okay, so does everybody have everything leveled correctly? Okay. If the cafeteria serves popcorn, so right here we are, we're at popcorn, we're having popcorn, there is a 90% chance that we'll also have soda, which means there's a 10% chance we won't. If they don't serve popcorn, so no popcorn right here, there's a 45% chance they'll serve soda, which means a 55% chance they won't. You okay? So, they serve popcorn exactly twice each week. So 2 out of the 5 days they serve popcorn. So what's 2/5? 40%. So 0.4, 0.6. 2 out of the 5 days we have popcorn. So 2/5. 2 divided by 5. 0.4. Now, what's the probability that we will serve soda? So we need the branch that gets us to here and the branch that gets us to here. Those are the soda branches. So start at the top, work your way down to that branch. We're gonna multiply 0.4 and 0.9 because we're having popcorn and soda. Over here, we're gonna multiply 0.6 and 0.45 because we're not gonna have popcorn and we are gonna have soda. And then what will we get numbers here? What do we do with these two numbers? Add them, because it's either this branch or it is that one. This or that. So what does our answer come out to be? Did you get 0.63?
Yes.
For your final answer, I mean, the final? So what's the probability we're gonna have soda? 0.63. So, before Jarius told us this was gonna be a pyramid problem, did you all know that? When you read it, did it feel to you like, oh yeah, this is gonna be a tree diagram? All right, now what does number 11 feel like when you read number 11? It's gonna be a Venn diagram. Because you've got a group of people and they're doing a couple of things and some of them are overlapping. So we have 60 kids all together on the bus. 40 of them say they like teaching, and 35 of them say they like nursing, and we see immediately we have an issue. Do not be one of the goofballs that puts 40 and 35. That doesn't make sense, because why? There's only 60 kids on the bus. So you can't have 40 in this circle and 35 in this circle. That isn't gonna work. So what's going on? I only have 60 kids. What happened? 15 of them like both. 15 of them raised their hands both times. Now I can fill this in. This one would be 25. And this one would be 20. And the question says, how many like only nursing? Only nursing would be those 20 people right there. Everybody got that? Okay. Now we have our expand problem. This is gonna be the one that's gonna take you the longest to do, probably. You're just gonna do it carefully, step by step. So here we go. 2x plus 3y to the 4th. All right, who remembers from yesterday? What? Pascal's triangle? Because I start by setting up the framework of the problem with just a string of numbers. And the numbers I'm gonna use are gonna be the 4th row of Pascal's triangle. So we start with 1, 1, there's row 1. 1, 2, 1. I really don't want anybody memorizing Pascal's triangle. I want to make sure you know how to build it. Everybody see where this 4 came from? I added those two. I added those two. I added those two. Right? And that's the row I need. So that's the 4th row. 4th row. So 1, 4, 6, 4, 1. There it is. Good? Now what? That's step 1. Get those numbers in place. Now what do I do? Put next to each one of these, I'm gonna put a 2x and a 3y. So 2x, 3y, put them in parentheses. I know it takes a while to write it out, but do it, you gotta do it. So that's 2x and a 3y. Now what? Now I have to put on my exponents. There's a countdown, remember how that works? So we start on the x, start on this guy first, and he's gonna be a 4, and he's gonna count down. Right? And remember, if you put a 0 on something, you can kind of get rid of it, because anything to the 0 is just 1. And then I'll do the same thing, go in the other direction with my y's. And I'll know if I'm right, because in each term, the powers are gonna have to add up to 4. There are 5 separate terms here, so I'm gonna put plus signs between them. Always plus to start. Sometimes they turn out negative, but they start out as plus. And then here we go. What's this equal? And if you say 2x to the 4th, I might come back and smack you. It's not 2x to the 4th. What is it? 16. X to the 4th. Why is it 16? Because you put that 2x in parentheses. And 2x to the 4th means 2 to the 4th, 16. All right? Now what? Let's look at the next term. What'd you get here? Now, you're multiplying 3 things. You're multiplying a 4. What's this? 8. And 3. At 96.
Yeah.
X cubed y. Now we're multiplying 3 things again. What are we multiplying here? A 6, a 4, and a 9. 216, I don't know, is that right? 216. X squared, y squared. And then, see if you can do this one. What are we multiplying here? We're multiplying a 4, a 2, and a 27. Did you get 216 again?
Yep.
And then the last one is a little easier, because you only really have that one thing to worry about. And what's that gonna be? It's our last term gonna be. 81, good, y to the 4th. 81, y to the 4th. And here's your answer. It's a lot. All right, anybody have a question about that? I'm gonna erase it.
Why does some of the exponent stuff, like we keep, like for this one, for 216, we kept the 3, but for, wait. we just drop the exponent, like, to the final answer?
What are you talking about?
Like, for the exponent of 96 times 3, and then like the x to the square. Is it just because it's the same? I answered my question, yeah.
Okay. You gotta figure it out.
Yeah.
Okay. All right. Now, the next problem is about the same thing, except luckily we don't have to write out the whole deal because this one is to the 8th. And you understand what that means. If it's to the 8th, we need the 8th row of that triangle, and there's a lot of numbers in the 8th row of that triangle. So if you thought this one was big, that one's gonna be about twice as big. It's gonna be huge. Luckily, we don't need the whole thing. Luckily, we only need the 5th term. So like in this big long list, we only need the 5th term. So what do I have to do first? I gotta figure out my number, right? Like I started by writing these down in the last problem, I gotta figure out my numbers. Now you have two choices. Could you keep building Pascal's triangle? Start with a 1, end with a 1, add. Could you keep doing that till you get to the 8th row? Yes. 100% yes. I am not suggesting you do or don't do that. You can. If that's what you want to do, it's fine. You can do it. The other option is to remember that the numbers in Pascal's triangle are the combination numbers for that row. So if I want the 8th row, the 8th row will be 8C8, that will be the first number. The second number will be 8C7, and then 8C6, and so on, just keeps counting down. So if I want the 5th term, I know the first term is 8C8, 8C7, 8C6, 8C5, 8C4. So that number, if I want, I can just find on my calculator 8C4. Okay? So you figure that out. And while you're doing that, I'm going to show you that it absolutely is true. So what's AC4? 70. And what is the 1, 2, 3, 4, 5th number in Pascal's triangle? 70? It doesn't matter which way you do it. If everything I'm talking about with these C's is like, forget it. Write out Pascal's triangle and find the 5th number.
Wait, so why wouldn't it just be 8C5 if it's that number?
Because it's not, we need the 5th number in the row. So 8C8, 7, 6, 5, 4. Just counting down, you have to count to get to the 5th one. So my number is 70. However you find it, your number is 70. Notice I didn't write out the whole triangle because I don't need the whole triangle. I only needed to get to the 5th term. All right, what goes next to the 70? Bryce and Jerry's, what is happening back there? Okay. What's next? After I write down my number, which is 70, what do I put next to the number?
X.
An X
And
and a negative 2y. And remember, that negative 2 is going to be multiplied. So it might turn out negative, just depends.
There's a exponent 4 and 4.
Okay, Derek says my exponents are 4 and 4. Now again, I want you to think about, when you put the exponents on, wouldn't you start with 8? And count down? So 8, 7, 6, 5, 4. Soon as you put a 4 on that one, because you counted down to 4, then you know that one has to be 4 because they have to add up to 8. Okay? There's no magic. You literally count 8, 7, 6, 5, 4. Now we simplify. Now luckily, there's no number there, so I don't need to worry about that. But this is a number. So what is that number going to be? Negative 2 to the 4th power is going to be positive 16 times 70. So did you get 1120?
Yeah.
And then of course we have our x to the 4th and our y to the 4th. Now the next one is a little bit tricky because this is in your notes, but we haven't done any censure notes. We've done a lot with C's, but we haven't done any with P's. Anybody remember how to do a P by hand? Derek?
9 factorial.
9 factorial.
Over 4 factorial. 5 factorial. Divided.
Just 4 factorial. If it's a C, it goes over both. But if it's a P, it only goes over the minus. Okay, so 9C5 would be 9 factorial over 5 factorial, 4 factorial. That's how you do a C. But the P starts with the 9 factorial, but there's only one number in the bottom, and it's the minus number. So 9 minus 5. So that's just something you have to remember. Now, what else do I need to see if I'm doing this problem by hand? I need to see the factorials, right? So what's 9 factorial? 9, 8, 7, 6, 5, 4, 3, 2, 1, over 4, 3, 2, 1. So all that will cancel. Now you can take your calculator out and multiply these numbers together. So, did you get 15,120?
Yeah.
So I'm not telling you you can't use your calculator at all. You can. I just need to see this and this. And then you can use your calculator. Okay, everyone? Okay. 15. We have another apple and banana problem. .65 does not go into your picture. 0.8 does not go into your picture. 0.55 does go into your picture, and where does it go? In the middle. So 0.55 goes right here. Now, what's going to go right here? 0.1 or 0.10, up to you. Because the whole apple ball has to be 0.65, and you've already put 0.55 in the middle. And then what's going to go over here? 0.25, because these have to add up to 0.8. What does this first question mean? Question A. What is that saying?
Not apple.
Not apple. and bananas. So in other words, I'm in the B ball, but I'm not in the A. So the answer would be 0.25, just B. Just B. What does the last question ask? Neither one?
Yeah.
Well, that would be people out here. How do I figure out who's out here?
Add 'em
What do these add up to?
1.9,
0.9, which means there's another
0.1.
0.1 outside. Because if your problem is involving probabilities, and that's what the P stands for, then they gotta add up to 1. So the answer to the very last question would be those guys right there. They're not in either wall, they don't like either one. All right, 16. Assume that one student is chosen at random from each class. Okay, so we have the same, I think it's exactly the same as yesterday, but different questions. What is the probability of neither liking science? So not science and not science. Now notice it's a not science. So what does that mean?
Everything else.
Everybody else. Everybody else. So if you are not science, then you are what? In class 1, you would be 0.9,
Times
and in class in class 2, you would be
0.8.
0.8, so 0.72. Not and not. What is the probability that the first likes English and the second likes math? All right, so English for the first class is 0.2. Math for the second class is 0.4. So the answer is 0.08.
Don't you want?
Huh?
Aren't you supposed to? Never mind.
Whoever remembers it right.
No, yeah, no, that's right.
What is the probability that both like English? So English and English. So 0.2 and 0.3, 0.06. All right. And then we got the tricky one. What is tricky about D? It doesn't specify order. So you really have to do 2 problems. You have to do math and art, or we have to do art and math. Does everyone understand that from the problem? So here we go. Math and art, or art and math. So 0.06, 0.04, and since it's one or the other, what do I do with those numbers? Add them. So your answer is 0.10. Okay, everyone? Here we go. Practice test 3. How many outfits can I make if I have 10 jumpers, 12 shirts, and 2 pairs of shoes?
240.
How many?
240.
240, that's exactly right. How did Jack get 240? Multiplied all of them together. Options times options times options. Very, very good. How how many ways can 8 people be seated, keyword, around a campfire? 7 factorial. What's our rule for seating or arranging around? 1 less. So if I put these 8 people on a bench, it would be 8 factorial. But as soon as I put them around, it is 7 factorial. So 5,040. 5,040. How many ways can you answer 10 multiple choice questions if each question has 3 options? So multiple choice A, B, C.
So each times
3 times 3 times 3 times 3 times 3, 10 times. So basically 3 to the 10th, which is a very large number. 59,049. That problem, you guys, is no different than the outfits problem. How many options do you have for question 1? 3. How many options do you have for question 2? 3. We multiply our options together, just like we did with the outfits. What is the probability of being dealt a 5-card hand with exactly 4 hearts? So it's a probability question, so I know my denominator is 52. How many cards in my hand? So 52C5. Now what does the numerator look like? Is everyone okay back there?
That's what the answer was.
What?
Yes, what the answer was.
Okay. What's my numerator look like? What do I need? 4 hearts. How many hearts are in the deck? 13. So isn't 13 C4? Isn't that 4 hearts? But what? There's another card. Remember, how many cards are in this hand? 5. So 4 of them are hearts. What is the other one? I don't know, not a heart, right? So how many not a heart cards are in the deck? 39, and I want 1 of them. So I want 4 hearts and times 1 other card that isn't a heart. Now, some of you seem very tired today. I'm not sure why that is, but I need you to get your calculator out and then type this in. This doesn't take much energy. I actually got a bigger number than I thought. 0.103, is that what you got? Did anyone else get that? No?
I got 0.01.
Yeah.
That makes more sense. Mine's too big. Let me see what I did wrong. Let me try again. 13. 4.
I got 0.01.
Oh, I see what I did wrong. I see what I did wrong. You're right. I knew that number was too big. You're right. 0.0107. Is that what you came up with? So there's basically a 1% chance that that will happen. 0.01. All right. Number 5. Another 5-card hand. So 52C5. All face cards. All face cards are in the back.
Yeah, 16.
What are face cards?
The
The ones that
jack,
faces
jack,
people. So Jack, Queen, and King. So there's 3 face cards that are diamonds, 3 that are hearts, spades, and clubs. So altogether, how many face cards are there? 12. And you want how many of them? 5. So your numerator is 12C5.
That's a part of 52. How much you would put some money on? Put some money on.
Watch your scientific notation. Did I type that one in right?
To be honest.
Wait, just 4? Are jokers included?
No. Because if jokers are included, then you have more than 52 cards.
That's why I told him. Try to tell him.
All right, does this number look okay to everybody? And we're gonna be careful when we get something like that, that we include this part in our answer. Don't just have the first part, then you'll be wrong. All right, there are 80 seniors in the math room. All of them enjoy matrices and or vectors. 48 of them love matrices, 42 love vectors. How many like only vectors? How am I gonna set this one up? Venn diagram, absolutely. Because you've got these 2 groups of people, your vectors and your matrices people, and they overlap. And there are 80 of them altogether. 48, when I took my vote, how many got matrices? 48 said yes. How many like vectors? 42 said yes. Remember, there's 80 kids in the room. What's happened? 10 have voted twice. And if 10 have already voted for vectors here, then this must be 32, because those have to add up to 42. I put vectors there. So vectors, and then matrices, this would be 38.
Yep.
How many like only vectors? 32. How many committees of 5 Republicans and 3 Democrats can be chosen from a group of 10 Republicans and 7 Democrats? So I have 10 Republicans, and I'm going to pick 5. And I have 7 Democrats, and I'm going to pick 3. Any thought about that? Order doesn't matter. Carson says 10C5 and 7C3. I agree 100%.
I like that stuff.
We're not arranging these people, we're just plucking a few out of each pile. So then what am I gonna do with those 2 numbers? Like that, I can get that number and I can get that number. What am I gonna do with those 2 numbers? Why am I multiplying them? And it's Democrats and Republicans. So I'm gonna multiply those 2 numbers together. Yeah, I got 8820, 8,820. ways can I line up 4 kids in the hall? 4 factorial. I'm lining them up in the hallway. Straight line. Lining them up. 4 factorial. So the answer is 24. How many ways can I give 5 identical pencils to 5 different students in a class of 8? So I have 8 kids, 5 of them are going to get pencils. Would you say?
8C5.
Karsten says 8C5. Is he right?
Yep.
Yep, because the pencils are all the same. So he doesn't care if he gets the first pencil or the last pencil. 8C5 is what? 56? How many 10 other words can be formed from the letters of the word calculator? So first thing you want to do is count the letters. I know they tell you there's 10, but count them. So there's 10 letters in the word. So we start with 10 factorial. Then what?
Count how many are
How many are repeating? Also, if I have 2 C's,
2 A's,
2 A's,
2 N's,
2 L's, yeah,
and that's it.
and that's it. And that is a triple division. Divide, 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 no multiplying. So 10 factorial divided by 2 factorial, divided by 2 factorial, divided by 2 factorial. And see if you get 453,600. Does that look okay? I don't trust
Yeah.
myself since I made a mistake earlier.
Yeah.
All right? Okay. Number 11. It's raining and we're doing homework.
Tree.
That's gonna be your tree diagram. And one level is going to be rain and one level is going to be homework. Since the question is, what's the probability that Tim will do homework? We know that's the bottom level. So we're gonna start with rain and no rain. And then we'll have to do homework and no homework. Is everyone all right with that? The way that I started that. If it rains, the probability that Tim does his homework is 65%. So this would be 35. If it doesn't rain, the probability that he does his homework is 0.32, which means no homework would be 0.68. Everybody okay? Jack? There is a 10% chance of rain. So 10% chance of rain. So 90% chance of no rain. Find the probability that Tim will do the homework. So will do the homework means this branch and this branch. So here we go. 0.10 and 0.65 are going to get multiplied. That is rain and homework. 0.9 and 0.32 are going to get multiplied. That is not rain and homework. And then since it could rain or not rain, I'm going to add those two answers together.
Yep.
All right, the next one is the big one, we don't have time to finish it, so I'm just gonna stop right there. We'll finish this tomorrow, and I'll have a little bit of extra review